Hello everyone. I welcome you to yet another lecture on the Concept Clarity lecture series by Clarity for Short and Agri Clarity platform. And today's topic of discussion is soil density, in that particle density and volume density. Okay. So yes, we know that simply density means mass upon volume. And yes, something if something is floating on water, something is floating on water, then it is less dense. That means the molecules which are present in that substance are not tightly packed, right? And if something is floating in the water, if something is sinking, right? Something is sinking, then it is called as a more dense, right? Because the particles in that substances are densely packed, right? So yes, this is what it means. That density is what mass upon volume, and these concepts in the soil science are really important from the perspective of the infiltration, percolation, the water holding capacity, because it is related to the porosity. Okay. So yes, let's just start with our today's lecture of the soil density. First, let's start with the particle density. Okay. So particle density is also called as a true density or absolute density. Okay. The particle means what? Here we are considering individual soil particle, right? The individual soil particle is considered here while calculating the density, right? So definition of particle density is it refers to mass of soil solids per unit volume. We see density is mass upon volume, but the mass of what? Mass of soil solids, and volume of what? The volume of soil solids. You can see here, right? Mass of dry soil and the volume of soil particles only. Why we are mentioning only? Because it is not considering the pore spaces. Okay, so the particle density is not going to consider the pore spaces while calculating volume. It is just considering the soil particles, and that is why we call it a particle density. That is a true density. Okay, here we are just considering the individual soil particle. Okay, that's simple, right? Yes. So particle density considers only solid portion of the soil and not air, water in the pores. Okay. So yes, I guess it is clear. Next, so the average or the average value of the particle density for the soil particles is 2.65 gram per centimeter cube. Okay, mass will be measured in the gram and the volume will be measured in the centimeter cube. Okay, so yes, the average value for the particle density is 2.65, right? So yes, this is again simple. And yes, the presence of some mineral materials or the presence of organic matter in the chemically present any minerals will have their impact on the density. Okay, it might be the particle or it might be the bulk density. Okay, so yes, their presence will increase or decrease the value of the uh, density. Okay, so yes, the formula for particle density again is the mass of dry soil and divided by the volume of soil particles only. So yes, but yes, you must have seen the statement that this particle density is a permanent property of soil, and it depends only on the chemical composition and is not influenced by the tillage and all. Okay, so why they are saying the particle density is permanent property, right? We see here that the presence of mineral and organic matter is going to increase or decrease the value of particle density. Then again we are saying it is a permanent property. How it is making sense, right? So yes, it is a permanent property because it depends only on the chemical composition and crystal structure. Okay, you can see here the range of particle density for it might be sand, silt, or clay. It is kind of similar. Okay, there is not much variation in the particle density because it is dependent on the chemical composition and crystal structure of that individual soil particle. Okay, so because of that, it is called as permanent property, right? and it is not influenced by tillage, compaction, and other changes in the soil arrangement, because we know tillage and compaction or the other arrangements are not going to have impact on the chemical composition, right? It takes hundreds and thousands of years to change that chemical composition of soil. We learned that in the previous lectures. So yes, as so for the same reason, that it is not influenced by tillage and compaction, the particle density is not that much important for us, but the bulk density is more important from the agricultural angle. Okay, so we will see that in the next slides. Okay, so I hope you understood that particle density is considering only the individual solid particle, right? And it is going to exclude the pore spaces. Okay. So yes, this was about the particle density. Next concept is the bulk density. Okay, so bulk density is what? It is the oven dry weight of unit volume of soil inclusive of pore spaces, right? So you can see here, bulk density is mass upon volume, but what? Mass of dry soil, but the volume of total soil including the pores, right? So here they are considering the pores, right? And it is always smaller than particle density. It is simple math, right? In particle density, let's clear this point. Particle density, and this is bulk density. Okay, we seen it is mass upon volume, but including the volume of pores, right? Here just mass and volume, and the no, it's just a solid. Okay, soil solids. So we are adding here soil solids plus pose, right? So we are increasing the value of denominator, right? And this is simple math, right? If the denominator is increased, the total value here is going to get reduced. And for the same reason, for this simple math reason, this bulk density is always going to be higher than particle density. You can see the ranges here. You can see this numbers and you can compare it with these numbers, right? So yes, please keep this in mind that because of the pores, we added the pore in the volume in denominator. This is going to get increased, and for that reason this value of bulk density is going to be reduced. Okay, so yes, this is the reason why it is always smaller than particle density. Okay, and in normal soils, bulk density generally range from 1 to 1.6. You can see here for sand is 1.6, for organic matter is 0.5, and all. Okay, so yes, this is the formula, as I said, mass upon volume, mass of dry soil, and volume, which will include the pores. Okay, so again, as I said, bulk density is kind of more interest for us, because the tillage and other factors are going to be have impact on the value of the bulk density. Okay, so yes, the simple math as I said, mass upon volume, right? Here we are considering the pores. Okay, and please keep one point, we want the ideal condition for agriculture is low bulk density. Okay, so anything, okay, we are doing tillage, which is good for agriculture, that means it is going to reduce the bulk density. Okay, the we know the crumb structure of the soil particle is ideal for agriculture, which means it is going to have low bulk density. Okay, so please keep this mind, keep in this way in your mind, so you will not confuse. Okay, so what is ideal for us? Ideal situation for us is a low bulk density, and with different processes and agronomic practices, we will try to reduce that bulk density. Okay, so yes, this is one point. And the next point that I want you to note down is the bulk density and porosity will have an inverse relation. Okay, so whenever the pore space is going to increase, the bulk density is going to reduce, and this is both ideal situation, right? We want a optimum number of pores, so they will have uh, 25 percentage of air and water, which is good for aeration and all the root respiration, right? So yes, more space is good for us, and it is going to reduce the bulk density, which is again good for us. So please keep in mind, the second point is bulk density is inversely proportional to porosity. Okay, and these two concepts are going to help you understand this chart. Okay, so yes, let's just start one by one. So you only tell me, if the pore space is high, so what it will have impact on the bulk density? Bulk density is going to low, because we cover bulk density is inversely proportional to porosity, right? Next, the fine textured surface soil again will have a more pores, right? Because of the same reason, it will have a lower bulk density, right? Again, more organic matter, which is good for soil, right? Which is good for agriculture and crops. It is good means we it is going to lower the bulk density. Okay, again, the crumbly, as I said, crumbly soil structure, we know it is ideal for agriculture, right? So it is going to lower the bulk density. Okay, tillage again is good for agriculture. We are doing it to increase the porosity, and also again it will temporarily reduce the bulk density. Okay, so yes. Next is continuous cropping is not good, right? It is going to create the compaction and all, will reduce the organic matter, and for the same reasons, it will increase the bulk density. It is not ideal, right? It is not ideal, which means it will increase the bulk density. Okay, again, as the depth of the soil is going to increase, there will be more compaction, right? And which means bulk density is going to increase. Sandy soil means higher bulk density. Okay, so these are the some of the factors which influence the bulk density. So yes, this was it of what I want you to take from this slide. First, bulk density is inversely proportional to porosity, and the next thing that I want you to keep in mind, that the lower bulk density is ideal for us, and with different practices we will try to reduce it to uh, this level. Okay, so yes. So why it is important? So as I said, it is going to help determine not only the total pore spaces, but also the macro and micro spaces, which governs the soil water air relationship. Right? It will directly influence the infiltration, permeability, percolation, water retention, because it has a relation with the porosity. Next, it is, as I said, lower bulk densities are generally favorable physical conditions. So yes, and the higher bulk densities are seen in the soil hard pans, which are going to restrict the root penetration and going to limit the volume of soil available for the nutrient uptake. So yes, we want what? We want a lower bulk density. So yes, the next concept here is the porosity. Porosity is the percentage of pore spaces which are present in the soil, which will help us to achieve the first. It will help us to identify the percentage of porosity, and it will help us to achieve the optimum, right? So yes, the soil porosity refers to that part of the soil volume that is not occupied by the soil particles or organic particles, but which is occupied by the pore spaces of soils, that means the air and water, right? We wanted 25 percentage of air and water, which is good for aeration, and that will maintain the optimum oxygen level for the root respiration and all. So we want this percentage, and we are going to first identify the percentages, and we will will practice different agronomic practices to increase it to this level, right? So yes, porosity, the formula for porosity is 1 minus bulk density upon particle density into 100, right? This is what is porosity. So yes, you can expect MCQs, the numericals on this topic in your exam, because the formula is easy, right? And yes, the calculation, if these values are easy, then the calculation will be linear. Okay, so yes, you can solve this kind of MCQs in less than 1 minute, and these kind of MCQs you can expect in your exam. So yes, let's just try this numerical, and let's find out the percentage of porosity. So porosity is, as I said, 1 minus bd upon pd into 100. So this is bulk density, this is particle density. Okay, so let's just put these values: 1 minus 1.00 upon 2.00 into 100. So yes, this is 1 by 2, right? So 1 minus 1 by 2 into 100. And we know 1 minus 1 by 2, 1 minus half is half into 100. Percentage, that is 50%. So the answer here is 50 percentage of porosity. That was simple, right? So yes, this is one example, practice example for you. You can try and comment if possible the answer for this in the comment section. So yes, this was it for today. We covered bulk density, particle density, and porosity concept. The bulk density is which is of more concern for us, and we will try to keep it low, right? Because this is the ideal condition for agriculture. And yes, it is inversely proportional to porosity, and yes, it is always less than particle density. Yes, and the porosity, the formula is 1 minus bd upon pd into 100. So these are the some of the concepts we covered in today's lecture. So yes, thank you for watching. See you in the next.